My name is David Benoit. This is my colleague Tim Beck, and this is our presentation on why middleware is dead. We've been building middleware for a long time in the software game, and we don't think we should anymore. We think that Postgres is sophisticated enough to actually provide everything that we need. We add one simple extension. So Tim lost the coin toss, so he's going to do the presentation. I'm going to do the demo. So I'll hand it over to him.
All right. So, as David said, we think middleware is dead, or at least on life support. But I'm going to give you a bit of history why it makes sense to us by covering a topic that is not only software related, not only database related. It's a pretty big topic in general, especially in economics. I'm going to start off with history and ask if anybody knows what that is. Oh, wow. You don't look that old there. So this is a CD. Everybody knows this is a CD. And back in the day, you have to actually go out, drive to the mall, find a music store, and purchase one of these. And then you have to go back home, put it in your CD player, and play it. And back then, that was okay. That made sense. But looking back now, it's insane because of iTunes, Amazon MP3, Napster. They completely changed how we consume music. Now, I know there's still some people out there who use CDs, but I'm willing to bet most people at this conference haven't touched a CD in a while. I certainly haven't. I don't even know where my old CDs are. I have a box of them somewhere, but all our music now is online. Purchase it online, but without moving anything but our hand. And so this is a really good example of disintermediation, which is a nice big word that I'll talk about for a few minutes. But I'm not going to get too much into it, because you can Google it, which, incidentally, is another example of disintermediation. It used to be that you had to go to these big buildings called libraries, and you had to get these things called books, and you actually had to read it, and you could even pay people to do this. And then Google came along and got rid of all this process, got rid of all this expense in the middle. And we can just go, again, without even getting up, and figure out what disintermediation is. So we have the music industry. We have Google. We have Dell was a big one, right? Anybody remember, dude, I'm getting a Dell, right? That guy, you called up and you said, I want a laptop with whatever RAM and disk, and they sent it to you. And you're talking directly to Dell. And of course, Apple, not only iTunes, but your iPods and all that stuff, you go right to their website and there's no middleman. There's nobody in the middle. It used to be Dell and other manufacturers and Apple. You'd have to go to Best Buy, and you can still do that. But they've changed the game, and retail has changed the game by eliminating what's in the middle and controlling more the interaction and the relationship they have with their customers. Traveling, I don't know when the last time I went to a travel agent was. Real estate, again, it's not 100% that way. There's still lots of realtors going on, but there's services there where you can just sell directly to your consumer. And even from where I'm from, which is up north in Canada, the Canadian Wheat Board used to be the only place where you could sell your wheat if you were a farmer. And last year, the farmers got upset and they said, no, we don't like that process. We don't like that expense. We want to be able to go directly to our consumers, which in their case is the factories that make the flour and whatnot. So they wanted to sell their wheat and barley directly. They want to get rid of the middleman. So to talk about our ideas of middleware, we wanted to also talk about, first, the benefits of disintermediation. So obviously in economics, I think it's pretty clear that it's gone that way. And the reasons that it's gone that way in economics can also, we believe, be applied to software development. So cost control and speed, obviously reducing cost is great for everybody. control of the relationship, control of the connection between the producer of whatever it is, in our case, data, and the consumer of data is key. The more control you can get over that, the better you can do at it. And obviously, if you eliminate a bunch of stuff in the middle, the speed goes up, and that's definitely a good thing. So maybe get back out of economics for a bit and just talk about what I've done for, I don't know, 15 years, and probably all of you have for a while anyway. And I will just talk about the basic architecture of a web application. And so it used to be that there was a database, and you used it for data storage. That's where your data was. And there was this thing on the other end, a browser, that took some HTML that I got from somewhere and rendered it. And show how old I am. It used to even render it in text. I don't know if anybody remembers links, but I used to browse the web, took HTML, and made it a text page. It was really bizarre. I can't even imagine ever doing that. But that left a whole bunch in the middle for this thing to do. So things like HTTP request handling, and I'm simplifying this greatly. So there's lots of things that are missed, but you'll get the idea. Connecting to the database and dealing with that. Manipulating data that came out of the database. Business logic, whatever that means. But basically for a web app, doing something with your data before it gets sent to the browser that is specific to your business. And then HTML creation. So it used to be HTML was like what was going to the browser. And now, just like music, and thinking back, that it was crazy that we would get up and go out and go to HMV or whatever and buy a CD. Now it seems crazy that we used to create HTML on the server. So this used to be the model a while back. And it's gotten better because of a couple of reasons. One, our clients have grown in power and type. There's more bandwidth, and they can do more. So not only can they render HTML, but they can actually do a lot of data manipulation if they can get their hands on the data. A lot of business logic these days is actually right in the web app, right on the client. And of course, they create the HTML themselves. They don't consume HTML over the internet. They actually consume data through, used to be XML, now more often is JSON, and they create the HTML and whatnot, manipulate the DOM on the client. And the same kind of thing started happening. We started moving stuff closer to the data. So things like data manipulation and business logic even started going into the database, or just barely above the database, where it was an ORM or something like that, where you didn't actually do much work on the server in terms of, and when I say work, I mean development work. You did most of your database stuff, and then this ORM or whatever helped you do the work, or auto-generate, I guess I don't like that term, but helped you build the server code that accessed that data. So anyway, that left not much left in the middle. HTTP request handling, database connectivity, and that's about it. And as I said, we moved from HTML to XML and JSON, and so this is recent history, and the line's blurry in a lot of cases, but you can see where it's going. Right? Things are going outward, and we think this is more than an accident. This disintermediation thing of the middle is significant, and we want to know kind of where it's going to go. And so this got us thinking a while back about what the next revolution was, and it was funny because it was just a I don't know, it was David really that came up with the idea. Literally, like reading one web page, and you'll understand in a second what web page it was. It was one line of text, and it was Postgres 9.2, basically the release of that got us realizing that indeed we probably could kill middleware completely. So not only was it all that stuff was already doing, but it was the JSON type. It was saying, wait a minute, the JSON type, we can do JSON right in the database now, and we can do JSON on the browser. Well, we've been doing that for a couple of years at least. And so, if you think about a translator, there's no need for a translator if everybody's speaking the same language, right? And with a little bit of an extension on the end, and with a background worker in 9.3, actually, we can do it before that, but it looks like it's going to be even better with the background worker. You can do the request handling as well. And so you have all that stuff on the front still. There's kind of a mixture of business logic and data manipulation. And then you talk JSON right into the database, and you talk JSON out of the database, and there's this thing in the middle that does nothing. And so what does this middleware do? Not a lot anymore. And so is this the future? Is this what we're looking at in terms of a web application? To have nothing in the middle between the browser, and I use browser kind of generically. It's not necessarily a web browser, but it could be a native mobile client or even a thick client on a desktop. But the point is that the JSON, the data, is being consumed on the client and manipulated and created, and then the database is dealing with all that other stuff on the other side. So that's the question. Is this possible? Is it wise? We don't know. We've just been thinking about this for last year, and kind of it's technically, as you'll see, something we could do. But we haven't really figured out if it's something we want to do. Like I said, the trend of web applications has been going this way, but do we want to push it even farther, eliminate all this stuff in the middle? It seems like it's a good idea. Disintermediation, it's worked all throughout history to reduce cost, to increase control, to increase speed, and it looks like it's going to work here. And David's going to show you exactly kind of how he did it, how he used the JSON type and the extensions in Postgres, and how technically it looks like it'll work. And then whether, like I said, whether we want to do that is something still up for discussion.
All right, thanks. So one of the things one of the motivators behind this is we found ourselves, the vast majority of the business logic that we write is written in store procedures. And last year I gave a talk about auto-generation of interaction between application code, this middleware, and what's in the database, the store procedure that actually does the work. But more and more, we were running into this situation where we have infrastructure built up to auto-generate the JSON interface and auto-generate the database interface, and then this part in the middle is left simply translating JSON to a store procedure call. And then it becomes ridiculous at that point that that's all this piece is doing. I mean, yeah, there's stuff for HTTP and other stuff, but essentially the real meat of the work is take a request, validate it, and pass it on to the database. So the idea is push that into the database and let's make it work there. So let's see how this works. So I've got a simple extension. Doesn't really do much. Okay. I've got other code that's in there, obviously. So I'm going to start up a new PSQL session, and I'm going to create that extension, okay? Now, what happens in the background is I didn't use elog, I just have my own here. So it opened the log for me, and now I'm going to actually start it, if I can find it. Okay, and I didn't exit, so this is what I get for doing a live demo. Oddly, you need to drop it and then start it again, but that's okay. And why is it not working? don't know why it's not working. It is supposed to work. Yeah. Just a second. This worked like 30 seconds ago. Honestly. So while that's restarting, I don't know if that's going to fix it, but let's hope so. Yeah, so I actually meant to write this as a background worker, but actually during the last talk I got the last piece of information that I was missing from doing this. So this is just a simple extension. Maybe it was when my machine went to sleep. I don't know. Guess that should have restarted.
Live connection to the database.
Yeah, that's probably it. Sorry, this is. This is not supposed to happen, obviously. It's not running. So let's start it. There we go. All right, so it's shutting down. Okay, it says it's starting. And it says it's starting now. Any help? Some Postgres experts in the room here?
Maybe Middleware just doesn't want to die quite yet.
Yeah, maybe.
Keep that shine.
Yeah. Kill it. For real. All right. Yeah, there's something weird. I don't know what's up. All right, it's not running. For real this time. We'll start it. And we're connected. All right, good. Okay, so create the extension and we'll start. All right, now we're running. That's better. So I've got a simple thing in the extension to tell me what port it's listening on, and it's just tick just to recognize that it's actually doing something. Now over here, this is simple Chrome Postman, if anybody's used this for testing JSON stuff. The idea here is that the query parameter is the function you're going to call. Okay, so this is a store procedure you're going to call, and the input is the post data. So set your content type to JSON, set the function you want to call, and send it along. At the bottom, you'll see the result. So the result I have here is echo the current time and whatever the input was. So if I go over and I look at, well, what is that store procedure? That's it. Okay, so take in some, it was supposed to be JSON, and return JSON. Basically, take some query, okay, execute it, and return the JSON that's from that. That's all it does. Let's do something a little more complicated, though. So let's say that we've got some web application, and we've got a get message, and we decide, well, what does it do? So we'll send something in there, and we get back No, there's no data associated with that. But if we specify maybe an ID as 1, we can get back some data that's in the database. What this one does, if you want to see this query, this is a little bit more involved. So it takes in JSON, returns JSON, declares some data, selects whatever data is associated with the ID that's in that ID field that's in the data that was passed in, and then returns that as a row. I could have done this inside of here and done some other things, but I actually wanted null to show up here if I pass in an ID that doesn't exist. So, for example, if I go back here and I say ID 8, the result that comes back is going to say data null. Okay, so that's just a choice that I made here. You can do whatever you want. You can send in null if you want. You can send in fish. And in that case, you'll see nothing because there's no ID. So it's pretty simple. And then if you get an exception, I just chose to return the time and what the exception was, what the SQL error message was. So that's actually it.
Can you talk a little bit about what actually handles HTTP?
Yeah, so you look at if we want to look at the code for a second, it uses something called micro HTTPD, which is a GNU library, which is pretty simple, pretty lightweight handling of HTTP. This is not the one I want. This is the one I was hacking around with during the talk.
So this is a background worker running an HTTP daemon.
Yes, yes it is.
I think that one was
That was my attempt at making a background
that
worker.
was the background.
Yeah, this is just a plain extension one. So I wanted to get a background worker, and I was missing one detail, like I said, but Mikhail actually gave me the last piece that I needed for that. It wasn't well documented. That's a call out to fix that. But here, basically, all I do is include Postgres SPI, some built-ins, define the two functions that I have, include micro HTTPD, and I wrote this in C++ because I'm a C++ guy. So you'll see some stuff here. I have some basic constants that I deal with. I open a log on creation and close it when the thing stops. And start just basically calls my start function. If you want to go down and look at that start function, what it does is it starts this micro HTTP daemon, accept new callback on this function, accepting new connections, callback on this when you've got data, disconnect on things after 60 seconds if you've got an idle connection, notify me of completion so that I can clean up, and a logging thing. You know, if that doesn't happen, return errors. I've got to make this all Postgres-y, but this is a very quick prototype of what it does. And then a simple, if you are familiar with asynchronous processing, a simple loop forever, okay? So tick, reset some select handles, get those select handles from the micro HTTPD daemon, set my timeout, adjust my timeout accordingly to whatever it wants. So I have 1 second, maybe it wants half a second, I adjust it there, and then select, and you're done, okay? What that does, up above, we'll see here, this is actually only 400 lines of code, if anybody's interested. When you accept a new connection, just log. But when there's data on a connection, if we've got a new connection, check to see if it's the right version, check to see that it's a post, because I'm only accepting post in this demo. I've got my little hack here to stop the daemon by sending it a stop request, which I wouldn't do in production. Look up the content length, get the content length, make sure the content type is application JSON, and then create a new request object, and then subsequent calls to this add more data to that. Okay, so that's what that does. The request object itself is what actually handles that data. So when I get data, basically append the data in. If I've got to respond, but here's the thing. When I'm finished receiving the entity, I just make an SPI call. Okay, so my SPI call is select mid dot whatever the function was, so whatever that query URL was, and yes, this is totally open to breaking right now because I can send lots of crazy things in here. But escape out the details of the JSON that's passed through, call SPI, execute on the query that I made, get the value, and then build a response from the micro HTTP daemon to send that in. That's it. So this is still technically in the middle, but it's not anything more than simple HTTP handling, response handling, and marshalling of a request with entity data to a function and the parameters that go to it. Okay, I don't want any logic in here. I don't want anything else in here because I want all of that to be in the database because it actually can be there. From the front end, from the JavaScript side, all it's going to do is call back on a normal, what is it called? A normal AJAX call. I don't do that part. So it's just a normal AJAX call, which is exactly what this Postman extension is doing. Okay, so I can, unlike JSONRPC, which is similar to this, what this allows for is the passing of complex arguments. Okay, so JSONRPC, you have to serialize everything into a named argument that goes as an argument to your store procedure call. This is just, here's a JSON blob as your input. You want to extract keys from it? Great. You want to use it as data that you store somewhere? Great. You want to use it as a complex relationship between vaccines and diseases and protections between those? Great, let's do that. You want to use it to execute a trade on a trading floor? Great, here's the information you need about that. But I guess the point is there that you don't have to take a complex object and make it into a serial version of arguments that are table-based. Instead, you can just pass in the structure and just store the structure, just manipulate the structure in the store procedure there. That's pretty much it. Any questions or comments or suggestions?
That's the comments. And I think, I mean, here's where it's interesting. So, having to, deal with both sides of the equation, which, yes, so handling like all the AJAX and the fun and all of that. The interesting thing is a lot of what the web server used to do is, when you make the request, you'd be putting together all the HTML on the web server and then sending it back to the client. And I can tell you now, I've actually been doing more and more on the JavaScript side, which a year ago I never thought I would say that, and I was religiously against that. But I think my concern, with having more of the HTTP processing in the database side, which first I think is a great idea, and I think this is probably a way to do it. I'm just worried that one of the resources that I do have in my OLTP apps is the CPU that I can handle the reporting, I can handle a lot more of the functional calls, and not worry about my database becoming CPU bound. But if I start sending all my web traffic at it, that's an easy way where that's going to start piling up and eating up my CPU, and I think that's probably where I guess some of the more benchmarking experimentation, trying to figure out what's going to be the right way to configure it on the database side.
Right. Now, I wouldn't suggest sending all your web traffic, just your AJAX calls, right?
Well, but that's going to be most of my web traffic because I'm handling all my rendering and all my data manipulation on the client side is
Yes.
occurring on the
No,
JavaScript.
absolutely. But so right now, all that web traffic that's coming into your server, that's all being translated into backend queries to the database, right?
Basically, it's as you know, you're right because of course I'm just sending it the the JSON, the lingua franca, and and that translation does take place. Yes.
Yeah. So in my mind, it's not any more of a load to put. Yes, it's more load on the Postgres server. Okay. So if that is somewhere else and not your front end web server, yeah, maybe you've got to do something there. And certainly, the way we've done this is we actually have Apache front ends that will proxy through the right request URL off to this part and serve up static data and whatever else is there. And that also makes it so you can put the front ends where you need them. But the actual processing of these kinds of requests, I don't think it's much more overhead at all. It's a connection. It's a couple, some headers. It's not very much at all, especially if you have a thin layer in between there that also manages things like certificates for you and all that crazy stuff.
But no, I think the point's good though, is that I don't think we're firing all our web traffic at it. I mean, you definitely have to be careful about that. No,
Right.
no question. But like David said, basically with the right architecture and the right setup, maybe with Apache in front of it.
Yeah, and that's sort of what I was thinking, that there's a way to engineer a solution out of this that it does come down to your architecture.
Yeah.
Yeah, I mean it's very interesting.
Yeah, well, I mean, that's what we thought. And like I said earlier, a discussion, we want to kind of get feedback. And like, I don't know, I mean, I've been doing web applications for a while, and this struck me as kind of weird, to be honest.
Well, the other thing about it is that by adding an HTTP server into the database, you're potentially adding an extra source of instability. That would be my main concern, apart from performance issues. I mean, you could probably easily achieve something like the same effect. That is to say, in effect, have a dumb HTTP process externally using Node.js, Nginx, Apache, or what have you, and but with no logic in it. It's just basically going to take your JSON file and
Yes.
spit it in the database, and it doesn't really matter what it is that does that.
Yes, and we have actually, well, I've experimented with doing that. It's a standalone server, and all it does is it does the HTTP handling. It takes in whatever entity was thrown at it and calls a store procedure.
Yeah.
The difference here is that you're closer to the database. That execution of the store procedure should have less latency associated with it, and there shouldn't really be that much more, assuming things are written well, there shouldn't be that much more risk associated with that. It is a separate process. It's a background process. I mean, it would be a background process worker in this. So if this dies, it's not going to bring down everything. It's a process running on its own, right? It's just, you're shrinking things down to the point where why do you have this level of interaction in there? Think of this more like PSQL client, but it's HTTP instead of typing with your fingers. But certainly it can be written that way. Yeah. I mean, one of the triggers for thinking about this is actually a talk that from last year about embedding PLV8 and making a JSON only or JavaScript only service. And I think it was actually sorry?
I said it was somebody else. I remember that.
Was it Will? Or was it, I don't know. Anyway, what struck me about that talk was that there was still this piece in the middle that was written in, I think it was Ruby, but it wasn't JavaScript the whole way down. It was still this piece that was in the middle that was translating. So I'd like to get rid of the translator. I don't like them. So, comments, suggestions?
Have you thought about authentication and most of the websites that we deal with?
Yes.
It's heavily user authenticated.
Yes.
So
So,
if you're still having the Apache on it or whatever web server on it that's handling that authentication in the session,
right,
so
so,
that you're not getting data.
so two things. One, my thought so far has been Apache was only doing the SSL state management. Okay, so dealing with certificates. So certificates are not that hard, but it's not trivial, right? But for user management and session management and managing those kinds of things, all of those, whenever you hit a request that needs to be logged in or needs to be authenticated, what are you doing? You're hitting your database. Your membership database is there, and you're going to look up, well, is this user authenticated? Is this session cookie that's in this HTTP header, is that associated with any existing logged in session that I have? Well, you just do that in the database here. You get the request, and yes, right now I'm only passing the entity data, but if you passed in the associated the associated headers and information from that, you can do that and just look it up. Is this session authenticated? Yes. Serve the data? No. Error out. And at that point, your responses can be richer because they don't have to be just HTTP error codes that go back. They can be a richer set of data that's there. And for example, you can have all of that inside of a WebSockets protocol. Because once you establish that WebSockets layer, HTTP is gone, right? Right. So you can't use any of that mechanism. So you have to use responses for each of the requests that you have. So that's how I would go about that. Our user management is in the database. Where do we go? We hit the database. The first thing we do is the person logged in? Yes. Okay. Then we can go to the database. Okay. Well, I can do those two things in the same request.
Yeah, anything that reduces the amount of traffic in and out of the database is going to be a win.
Yeah, for sure. For sure. But this is a background process, or this add-on extension or whatever you want to call it. The HTTP part of it is separate from the database. So we would be getting rid of. It would be the thing that would be handling, slow connections or large entities or anything of that nature. And it would still be kind of a gatekeeper into accessing the database from are you speaking the same language as me? But not from getting in my way of being this unnecessary piece that I have to deal with every time I want to change a function. Which is what we do now, right? We add on a argument to something, you've got to change the piece in the middle, you've got to change the JavaScript on the front end, you've got to change the procedure in the back end. If we can get rid of one of those pieces, we can make the time to delivery a little bit better.
And it's just less complex, which, in my view, is always good. Reduced complexity is something I believe in, and this certainly does it. Reduce complexity at all costs. I don't know. That's always a balance, right? That's the game we play.
Have you tested this out under any sort of load, in particular with concurrency and that sort of stuff?
This one, no. The standalone prototype that I did, yes. The reason I had, actually one of the things I was going to ask about here, one of the problems that this has is that it uses SPI. It's a good thing and a bad thing. It's a good thing because it's close to the database and the execution has less latency associated with it and some other things that are good about SPI. The bad thing about it is that there's no asynchronous interface to the SPI. So I can't post a query and tell it to call back to me later when it's done. I have to wait for that to execute. So if the store procedure that I'm executing takes a while, I have to wait. So because of that, the model of request handling has to change a little bit, where the standalone server that I built as a prototype, it is fully asynchronous, and it's basically a request comes in, I get the entity, I fire off a request to the database with a new connection or a pooled connection or whatever it is, and that just happens. So no, I don't have any performance numbers right now, but it will be different using SPI, and the approach to managing the level of concurrency that you want using an SPI-only model has to be a little different than if you have it as a standalone process that can take advantage of external connections as needed. So it's not obvious, but it's something to think about. I think it's worth the thought process of what a model like this could do to remove complexity of building systems. Essentially, at this point, you've got, and I'm not saying that you won't have any custom code that's connecting to the database, but I'm saying that the piece that connects the user interface to the database can go away. You might still have logic that, you know, does some other complexities not related to user interfaces. But for this part, I think that we can make this a lot better. That's it.
Thanks.